Alright, this is chapter 5, number 17, part E. So there's a picture there. We don't need to the picture down. But it's a good idea to create a free body diagram. It actually says that it wants the acceleration of the system, of the entire system. There are two boxes, and they want to know the acceleration of the two boxes. The fastest way, what you can do is you can find the acceleration of each box and work it out that way. Do several drawings and figure it out. But the easiest way to do this is just picture them as one big box. So one is 65 kilograms. That's mass 1. Mass 2 is 125 kilograms. The applied force is 650 newtons. And the coefficient of kinetic friction is 0.18. No units because it's a ratio. Alright. So, there's the applied force on it. There's a force of gravity. There's a normal force. Okay, this is the force of gravity. I'm trying to get them as even as possible to make it a little more accurate. And friction force. Now, whenever you do a free body diagram, I keep forgetting, but it's best that you don't forget. Draw an arrow above the force, the S. It shows that it's a vector. You only need to really do this for the diagram. The diagram is just an indicator of which are vectors and which are scalars. To me, it looks a little more confusing. That's probably why I don't usually do it. But I think that's the way they want to see it, so you should have that done. The total mass is 65 plus 125, so that's 190 kilograms. Okay. In order to find the mysterious acceleration of this mysterious object that weighs 190 kilograms in two parts, is to take the sum of all the forces in all directions. But we already see that it's not flying up in the air and it's not falling through the floor. So there's no acceleration in the y direction. There's only an acceleration in the x direction. So if we were to take the sum of the forces in the y direction, we'd see that it's 0. It's almost not worth doing. Okay, so sum of the forces in the x direction, however, is the applied force minus the force of friction. And that will equal an acceleration. That will equal mass times acceleration. So, let's spell this out. The applied force minus the force of friction, which is mu mg. This is kinetic. Let's make sure that that's in there. Okay. And that equals mass times acceleration. Divide both sides by m. And you get the applied force over m equals, whoops. Magic. Minus mu k g equals the acceleration. We have the applied force at 650 newtons. We have the mass. The mass is 190 kilograms. In fact, I'll plug this in because just to be clear, it's the total mass that we're talking about here. This is a T. A what? A T. A what? A T. Oh, a T. Okay. So 650 newtons divided by 190 kilograms. The exciting, amazing 190 kilograms minus 0.18. Can you feel the excitement build? Times 9.8 meters per second squared. Equals acceleration. The acceleration is in, would be using it, yes, we will be using the acceleration later on, so let's write out the whole number. 1.657 052 632 meters per second squared. The acceleration in significant figures is 1.7 meters per second squared. Okay, that part's done.